This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Good morning, welcome for the 13th week now. We are in the end. We should cover some examples. We are going to go through arrays today, but not the arrays that we saw last week. Also, we are going to see them again, but we are going to see a new kind of arrays called built-in arrays. Okay. Before starting, do we have any question about anything unclear up until now? From the beginning of the semester up until now, including the midterms. No questions, again, for the newcomers, the ones that just came. You don't have any questions, so we can continue. Okay. I hope you remember the arrays from the vectors, basically, actually, from the last week. We're going to do something similar today. So if you have not downloaded your code yet, please download them. And while they are being downloaded, let me go through the theory behind today's classes. Basically, we'll talk about built-in arrays. You remember what an array is, what a vector is, okay? Instead of defining multiple data, like if you want to keep the grades of the students, and up until your graduation you have like 40 grades, and you don't want to put a single variable for each of them. Let's say double CS201, double Math 101, double something else up until the end. You just declare it a vector and you put your grades there. The interesting stuff with the vector that you saw last week was that it was constant. It was dynamic. You can add data, you can delete data, and so on. But today we are going to see something else, which is very similar. We are going to see basically built-in arrays. They are not dynamic. The only difference that you should know for the time being is the following. Yes, you also should give the size of the vector initially, but that size cannot change. Okay, it's going to be constant. So if you say that the size of my vector, of my array, is going to be 40, it's going to be 40 forever. Also, there are some differences in the way you declare them. Namely, it's going to be something like this. First, you say the type of the array. You say the name. And here, in those brackets, you put the size. And you put semicolon. This is it. Basically, if the size is 10, let's say, if this is 10, what you're doing is the following. You're declaring an array that has 10 elements, starting from index 0 up until index 9. And the type, meaning all the elements in this array, in this vector, all the elements are of the same type. You cannot say, okay, in the first cell here, I have an integer, and then I have a double, then I have a string, then I have an integer again, then I have another integer. No, all of them are the same. If you want to access a certain data of a certain index, you're going to do it, as you remember from the last week, like this. Name, I. So the name of the vector is I. You're accessing IIndex. So if you want to access the 0th index, you should write name 0. This is either for reading or for writing a certain index, okay? So let's say if the type is integer, so integer name, let's say the name is again name, and we have 10 arrays. So this is my vector name. And here I have some integer data. Let's say I have 3 here, 7 here, 5 here, at the 3rd index I have 2, and so on. And if I want to access the second element, I'm going to do something like this, name 2. And what's the value of name 2? It's 5. Okay, actually I'm saying name 2 is equal to 5. If you want to print, if you say something name 2 is equal to 6, then this guy is going to be 6. Okay, if you want to print it with cout, you can do something like this. Name let's say 1, and you're going to print what? 7. Since the first index, actually the second index, index with number 1, with, yeah, the second index, starting from 0 is the second index, numbered as 1, its value is 7. So basically this should be all about built-in arrays. Again, when you say this size, I mean, even you cannot do something like this. Integer size, of course, sizes of integer type, because those, if we start from 0, we should go up until size minus 1. If the size is 10, this size minus 1 is going to be 9, of course. You cannot do something like this. Cout, cin, size. You cannot prompt the user to give the size of the array, okay? This should be declared before compiling. Okay, you know that I'm going to deal with an array and it's going to have, let's say if you're dealing with your grades and you always know that for sure you're not going to have neither less nor more than 40 grades, or at least not more than 40 grades, then you're going to declare an array which can be of type double, you can name it grade, and it's going to have 40 elements. If you want to have 41 elements, you cannot use it. Okay? So this is suitable and optimal solution when you know that your array is going to be fixed and of constant time. Okay? But it's not always the case. That's why we use dynamic arrays, meaning we can change the size of the array or the vector or array, and we add or delete element. Basically, with dynamic arrays, when you add an element, size increases. But okay, it's the topic of CS204, and you're going to deal with that in more details in advanced programming, in the course of advanced programming. So you should guess that we're going to cover first the built-in example from your codes. That's why just open it. It's test number 4. Copy this guy, paste it at your solution folder. Add it to your solution, this item, fixed list. Its name is fixed list. Now I'm going to show to you the output, the desired output, what you should do. So this is what you're going to have. Let me enlarge the font. Okay, this is it. So we have an array of 10 elements in our case. We print it before it's from 1 to 10, and afterwards, meanwhile, we multiply each element of this array with 2, and afterwards its array is going to be like this: 2, 4, 6, 8, 10, and so on. So it has 10 elements, okay? Basically, we have an array like this. I don't know its name. Its size is fixed. It has always 10 elements. And initially it has, the elements are like this: 1, 2, 3, 4, up until 10, because the size is 10. So the ninth index is 9. Now you know, probably, I mean, you know from the last week and also from the lectures, that if you want to print or change an array, you should do it with a for loop, something like this. You start from the first index up until the size. You increment the index at each iteration. And if you want to print it, you just print cout. If the name of the array is name, you print the ith index of the array, like this, name, and you print it, okay? You can have some end line here, meaning for each element we go to a new line. However, your code is not finished. You have to add something small in your code, but just let's go to the code. So the desired output is the following one, okay, as you see it. We print before, we print an array, we do some processing. The processing is doubling all of the elements of the array, multiplying them by 2, and afterwards we print them again. This is it. Now let's go to our code and see it. So, we declare two functions. One of them is double, called double. I forgot to tell you, but you can already see it. You should have known it from your lectures also. That's when you send a built-in array as a parameter, you send it like this. And it's always a reference. Basically, you're saying that this function double takes a vector, an array, as a parameter, which is of type integer, and always you should send the size of the array, because the built-in arrays don't have the property size, as you remember from last week. Okay, size gives the size of the array, but here you should explicitly send it to the function as a parameter. So you send it number of elements. If you try to access an element which is not part of the array, let's say the array has 10 elements. If you try to access the 11th, the 15th, or the 20th, or whatever element, which is not part of the array, you'll have an error. Okay, that's why you want to avoid it. For this reason, you send the number of elements of the array. So, double basically is a function that multiplies each element of the array with 2. And we have another function which is called print. It also takes two parameters. It takes an integer or a vector of integers. And again, it takes the size of that. In this case, it's all again given as number of elements. However, we have something called constant here. Why it's constant? Can you come up with a solution? Why do we have this expression constant? We have already explained it during the scope, in the scope of CS201. So, why do we have constant in the print function and not in the double function? Do you have any idea about that? Of course, you might be wrong, but you should know it, I suppose. So, yeah, I think you want to give an answer. Yes. When we are printing an array, we don't want to change it. We just want to print it. This is it. But in the first function, which is called double, we multiply each element of the array with 2. So we are changing the array, the content of the array. Okay? That's why we write it like this. So you might say, okay, when I'm going to print it, why I should put that const expression. Okay, I know that I'm not going to change it. Well, one of the reasons is the following. In many programs, it's very important not to change the parameters, not only arrays, any parameter, okay? And the functions, when you send it as a reference especially, you don't want to change it in many cases. And the function that you use there, the function is being written maybe by multiple programmers, okay? So one programmer might make a mistake and change it, okay? With this const expression, you don't let any programmer or the function change it. Okay, you know that for sure. I don't want to change it. I want to print it, manipulate with it in some way, but not change the content of that array. Okay, that's why you send this const. Even in this case, even if you don't write const, it's not going to be changed. But it's a good measure, preventive measure, to prevent mistakes of changing things that you don't want to change. Again, I repeat it again. Always, built-in arrays are sent as references, as pointers, but you don't know what a pointer is, so you can assume it's like you send them as a reference, meaning that if you change it, the change will be seen in main or the function that called that certain function. Okay. Now let's look at the double function first. So here we define it. This is a prototype function. Let's see how it looks like. Oh, we don't see them. Okay. We should write them from scratch. So, since we have a built-in array, we declare the size to be 10. We define an integer, an array called numbers of size 10 of everything is integer, of type integer. Then this is what we do. We fill in the array. Basically, we start from 0 up to the size. And numbers of k is k plus 1. Basically, if when the index is 0, like this, when the index is 0, we put there 0 plus 1. When it's 1, we put in the corresponding place 1 plus 1, 2. When it's 2, we put 2 plus 1, 3. Okay? So always we put, if the index is k, we put k plus 1. We do it with this for loop. Now we print before. As you remember it, let me show it again. So we print before, we print it here, then we print the array. We send it. The array name of the array is numbers. Remember, its size is size, but we should send both of them. It's always like that. Afterwards, we print after. We call the double function, which multiplies each element of the array with 2. We print the array again, as we can see it here. And this is it. The program terminates. Now our job here will be to write both of those functions, double and print. Can you do it? I mean, you see, initially we declare an array of size 10. We have 10 elements, but everything is empty. Now, depending on the compiler, those 10 elements will be assigned to zeros, but you should not assume that it's always the case. Okay? With this for loop, to each of those elements we assign a number, a content, okay? Which was, if the index is k, its number is k plus 1. So, if you want to access each array of each element of the built-in array, we use this loop. Now, if you want to multiply all of the elements with 2, how are you going to do that? So let's write the double function. Meaning that we send the array, and in the end, 1 should be 2, this guy should be 4, 6, 8, up until 20. How are we going to do that? Do you have an idea? Come on, guys. I know it's easy, I know you know it, but give an idea. What do you think? You have no idea. Come on. Okay. Just make a comparison with this stuff here. So, how did we assign elements? Like this. Okay. Now we'll use the same loop, but instead of assigning an element, we multiplied all of the elements with 2. So how do you do that? If you have a variable called a, how do you multiply a by 2? How do you do that? You say a is equal to multiplied by a. In this case, number k is equal to number k multiplied by 2. This is it. So let's write it. Okay, for integer I equals from 0 to I smaller than, you see the size is here called as number of elements. So num elements I++, and the name here is not called numbers, the list is not called numbers, the list here is known as list. The array actually is known as list. So list of I is going to be as list of I multiplied by 2. This is it, nothing else. Of course, a better way to write it is like this. List of I, I'm commenting it, multiplication, this is the same thing, equal to, but in a shortened way, okay? Now we should also print the list. How do we print it? You see, we print it like this, okay? 1, then new line, 2, 3, and so on. How do we print it? Come on. Is this too hard? Can I have a clue then? Okay, give me an answer about this one. Yeah. So, we're making a for loop. Actually, I wrote the answer somewhere. Yeah. You see, you mean a for loop like this. Okay, then see out every element of the list. This is it, yeah. List of I and line.
We didn't equalize I next to 0.
Oh yeah, you're right. If the compiler automatically initializes I to 0, then we don't need to write that, but you should do it always. Yeah. So this is it. Is this hard? No. So we go from size up to number of elements minus 1, up to size minus 1, because we start from index 0, from I equals to 0 to this guy. This is it, nothing else. It's so simple. Now, let's run the program. I don't have system pulse here. No, I don't have. That's why it's going to terminate without seeing the result. In your homeworks, you shouldn't do this. When you write your assignments, you should use scene, ignore, scene, get. But this is a bit faster for me. So this is the output that we should get, okay? It's easy, actually. Any questions about this program? Did you write it also or not? Come on, try to write it. You have 30 seconds for the first function and 30 seconds for the second one. Try to write it. I'll check that. And this will be counted towards your activity. Everything okay here?
Yeah, just I want to download it.
Okay. Is it working? It should. Huh?
I didn't run I couldn't run from it.
See, what's the problem? Yeah, because you didn't finish that for loop. That's why. Is it working here? Mm-hmm. Okay. If you have any question, please raise your hand and I'll come at your place. Yeah, I'm coming. Your homework, by the way, your 7th homework will be about arrays and vectors.
Shit, I did not do it the first time.
Yeah, it's okay, it should work. Yeah, but it's not working because you can either declare here or here. If you declare it here, it's valid only for this for loop. Outside you cannot see it, but if you declare it, it's valid for the whole function, okay? And this is something positive for the C++, because again, you can declare a variable inside this for loop. And this will be this in I of type integer, this variable, will be valid only for the for loop. You get the scope, the validity for this variable is only for this guy here, only for the for loop. Outside, you cannot see it. Okay, some programming languages does not allow that. Like let's say Pascal or Delphi or something like this, okay? And I mean, this is a good stuff for C++ because when functions get too large, you define a lot of indexes and variables, and you forget which one, where do you use, okay? So you might reuse I again, and I might be set at number of elements minus 1, and you're thinking 0. So you have mistakes. So this is the positive thing, one of the positive things about C++, and C++ like programs like Java or C# or whatever. Let's go with the second example. It's about student IDs. We can maybe run the demo first to show what we should do here. So basically this should be our output. We should enter a file name. And remember, I have here the executable versions. And when you are working with files, the file should be at the same folder with the executable version. So we are asking for the file name. And if you're wondering what student it's just about random names and surnames for students, okay? We have like 10 or 15 names and surnames for students. And this is what we want to do. So we enter the name, we assign IDs, we sort them, and we print them. Student.txt. So this is what we do. We assign random but unique, and this is important. We assign random and unique IDs. We sort the students by the ID number in ascending order, and we print them. Okay, so Jamie Bell, Colin Hanks. If we see in the student file here, as you can see it, Jamie Bell is where? Here. Okay, but Jamie Bell came here because his ID is the smallest. Then we have Colin Hanks. Colin Hanks is here, but he came at the second spot since his ID, unique ID, when sorted, is in the second spot. So this is our program. Now, in order to write that program, let me give you some theoretical backgrounds about the program. You know what classes are. And there is something lighter than classes, which is called the structure. If you understand classes, and we have been dealing with classes a lot during the scope of CS201, so structures should be something straightforward for you. Basically, everything that you have in classes, how you have in structures, or vice versa. So structures are kind of more lightweight. Everything inside the structures is public. You don't have public members, private. Everything is public. Just let me give you an example of a structure. So this is how you write or define a new structure. Let's say you want to deal with complex numbers, and we did something like this, like maybe two months ago, if I'm approximately. So let me do it with structures. So you define a structure called complex, okay? And here, because we are dealing with complex numbers, and yes, you know, each complex number has its real and imaginary part. So double, real, and double, imaginary. This is how you define a structure. Now, if you want to declare a new variable of class complex, you do something like this. So instead of having integer a, so type is integer, name of the variable is a, you do something like this, complex. Let's say z1. If you want to access the real part of this complex number, you write z1 point real. For the imaginary, it's the same, z1 point imaginary. You don't have anything public, private, or whatever. Everything is public, basically. You don't have to write it. It's understandable. It's understood that it's public. So these are structures, and in your assignment you will have a structure. Okay, something you will see in this example, something similar to that. What else? Dynamic arrays, we already saw them. So we saw built-in arrays, vectors. Array vector is the same thing. You can assume it is the same for the time being. You remember dynamic arrays from last week, but let me explain them very, very briefly again. So you have the class vector. Vector array is the same again. So this is vector. Here you have some public data. Of course, we have the constructor, blah, 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 but we're not interested in them. I'm going to write only the ones that we are going to use. So one of them is this operator I. One of them is size. This is a function. Returns the size of the vector. And an important one that we didn't see last week is the pushback function. Okay? So what are those guys doing? Again, if you want to declare a vector, you should do it in this manner. Vector. You have here the type of the vector, the name of the vector, and the size, which is an integer, of course. For instance, you might say vector char for characters, alphabet, and you have 26. Meaning you declare a vector of characters, which is called alphabet, which has 26 elements from A to Z. If you want to access, and it looks something like this. So this is 0, this is 1, this is 2, this is 25. Let's say somehow we put characters here, A, B, C, but all of the data is the same, okay? We cannot say again, we cannot say I have integer here, string here, double here, character here. All of them are the same. If I want to access, let's say, the first index, then I'm going to do something like this. Alphabet of 0, which is basically A. And characters are written in single quotation mark. If they are string, they're in double quotation mark. If they're characters, they have single quotation mark. Of course, you can use alphabet I. You access the I data with the IIndex. If you use alphabet size, this is going to return 26 in this case, because the size of the alphabet is 26, okay? It was not the case with built-in arrays. You could not use them with built-in arrays. What else? The most important part here is the pushback function. So if you use this guy, this function, so alphabet point pushback, pushback is, as you can see, part of the, is a member function of the class vector. And if you put something like this, let's say question mark, then you will have a new index here. Let me write it with another color. And here you have question mark, okay, with pushback. Basically, this vector, this array is dynamic, since you can increase its size. You could you couldn't do this, as you remember, with built-in arrays. And what else is left? Sorting. Do you know what sorting is? Of course you know, but give me a clue. What is sorting? Have you ever written a program to sort numbers or data or whatever? If you have a list of numbers and I say sort them for me, what are you going to do? What do I mean by sorting?
List only increasing or decreasing order.
Yeah, but what increasing? Arrange them in increasing or decreasing order, okay? So, let me give a sequence of numbers, one-digit numbers, 3, 7, 2, 1, 8, 9. And in the end, I want them in increasing order, ascending order. I want them sorted. Basically, what I want is to get in the end 1, 2, 3, 7, 8, 9. So can you come up with an algorithm to do that? We're going to do this during the third lecture today, if I'm not mistaken. How are you going to do that? With program, actually. Well, I have an idea, and this idea is the following. I'm going to explain them again. I start from here, and then I take the minimum of all of the list and I put it here. Then I go with the second index. So I start from here, and I check the data one by one. This one, this one, this one, this one, this one, of course this one. And I say, okay, 3 and 7, which one is smaller? And I put the index, let's say this is an array with index 0, 1, 2, 3, 4, 5. Okay, we have 6 elements. So in the first iteration, which one is smaller? 3 and 7. For the time being, I say, okay, index 0, whose value is 3, its value is 3, with the time being smaller. Then I compare 3 and 2. Who is smaller? 2. That's why for the time being, index 2 is smaller. Then I compare 3 and 1, which is smaller. Index 3 is smaller. 3 and, 3 and 8, or actually 1 and 8. So again, initially I assume I start from index 0. So this is the red one. And I compare them. And I say 3 and 7, which one is smaller? It's for the time being 0. I always, initially I assume it's 0 and I compare them. When I compare 0 and 1, it's 0. 0 and 2, it's 2. Okay. So I put index 2 here. Then I compare 2 and 3. Which one is smaller in terms of indexes? It's index 3. Then I compare 3 and 4. Which is smaller? It's 3. 3 and 5, it's 3. Okay. So in the end, 3 will be the smallest index. In the first pass, I swap the places of 3 and 1. Basically, 1 comes here, 3 comes here. So I have an array like this: 1, 7, 2, 3, 8, 9. Okay? Now, I start from this index here. I'm finished with the first one. Now I do the same thing for the second index. This is index, I'm going to write the indexes again. So this is index 0, 1, 2, 3, 4, 5. And I start and I say, okay, the minimum for the second pass, so pass 1, gave me this result, this array, sub-result actually. I'm finished with the first index. Now I'm looking for the minimum of the remaining array. And again, I compare 1 and 2. Which one is smaller? Well, 2 is smaller for the time being. Then I compare 2 and 3. Which one is smaller? Well, 2 is smaller. 2 and 4 with, index 2 and the value of index 2 and index 4. Which one is smaller? It's 2 again. 2 and 5 is 2 again. So index 1 should be switched with index 2. When I switch the places, so this guy should be switched with this guy. So I have pass 2, 1, 2, 7, 3, 8, 9. And I do it. So after the second pass, I'm looking for the third member. And eventually I'll come to the end and I'll have my sorted sequence in this term. Okay? So this is how I do the sorting. One of the algorithms. Sort, or sometimes it's called select sort.